Hello and what's up, everybody? We're back for another lesson. Today's lesson is called Get to the Point. And that's probably what a bunch of you are going to tell me today. Today's lesson, though, is on volume and surface area, mostly the surface area of 3D figures. So 3D shapes, spheres, prisms, whether they're rectangular, triangular, cylinders, cones, things like that. And we already talked about the volume a little bit with them, but we're mostly focusing today on their surface area. But first, let's start off by imagining and doing some like brain skills. So the first one says a stack of 100 copies of the same book. Well, we know books are mostly rectangles, right? But it's gonna have a base of a rectangle, so something that looks like this, right? But then if we keep stacking them, think about stacking a book, and it goes up, right? Boom. Stack the books. It's gonna look something like this, right? Something like that. And we're gonna get a stack that kind of looks like this. This is gonna be a rectangular prism. A rectangular prism. Let me rewrite that. That was not neat. Rectangular prism. Next one is 100 stacks of tires, right? All with the same radius. So we know tires are circles. So if we keep stacking tires, we're going to have a circle down here. Then we're going to stack those tires up, 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 up. And we're going to have that circle up here too, right? So we're going to have these stacks of tires. Now, obviously, my drawing's not that great. Don't tell anyone. But what is this going to give us? This will give us a cylinder. Boom, a cylinder. I had to sound it out. My head's not working right. And last but not least, a stack of 100 stop signs. Stop signs we know are octagons. So if we keep stacking them just like the books, it's going to give us a prism. But we're going to call this an octagonal prism. An octagonal prism. Bang, bang, boom. Nice and easy. So as I said, or let's call it get to the point. Our learning goal for today's use formulas for the volume of a cylinder, cone, and sphere to solve real-world problems. This should say volume and surface area, formulas for volume and surface area. And first thing we need to do is talk about our surface area. And it says, in a previous activity, you explored the different volume created by rolling a piece of paper in two different ways. The cylinders that you created had the same lateral surface area, right? The lateral surface area of a three-dimensional figure is the sum of the areas of its lateral faces, so the outside, not including its bases. So on a soda can, it would be the part where the label's wrapped around, right? That's the lateral surface area. Or on a can of soup, it's the part where the label's wrapped around it. The top and the bottom of that can of soup are not part of the lateral surface area. That would be the total surface area. So that the total surface area is obviously what it says it is. It's all of the surface area of that figure. So for prisms or rectangular prisms, we don't have lateral surface area and total surface area. We just have surface area. And we're given a formula here. It's 2 times the length times width plus 2 times the length times height plus 2 times width times height. And basically all you're doing is finding the area of each of these sides, right? That's why you have 2 of each, because you have 2 of each side. You have your front, back, right, left, top, bottom, right? So there's 2 of each side. But for our surface area on all other prisms, whether they're triangular, octagonal, hexagonal, any other prism, so it could have any base that's not a rectangle or a square, and you have a different thing here. You have your lateral area, which is going to be the sides, which is just your height times p, but p is the perimeter of the base. Your height times the perimeter of the base. And then your whole surface area is that HP, the height times perimeter of the base, plus 2 capital B, and that capital B stands for the area of the base. So you might use different formulas there. Depending on what the area of the base is, And what shape the base is, you're going to use different formulas. If it's a triangle, you use 1/2 base times height. If it's a rectangle, you use base times height, right? But rectangles we're not going to do this for. If it's an octagon, you'll use whatever that formula is, so on and so forth. Next up, we have our formulas for pyramids. For pyramids, it's going to be our lateral surface area is 1/2 L, which is our slant height. So the height of these sides, the slant here, times P, which is once again perimeter of the base. Same thing as last time, our total surface area is going to be that plus the one base that we have here. We don't have two bases, so we're not going to have that 2B here. Where in our last formula, we had a 2B because there was two bases, the top and the bottom. Here we only have one. And next up, cones, which is kind of the same. It's going to be pi r squared, which, because we have a circle, we're dealing with a circle. Sorry, not r squared, pi r times L. And remember, for pi, we use 3.14. So L is that slant height again, the height of this slant, or the length of this slant here. And then for our total surface area, it's pi r squared plus pi r L. And once again, these are going to be a lot easier once we start doing problems with them, right? And all you have to do is basically plug numbers in and solve. And last but not least, we have our cylinder. The surface area for a cylinder, the total surface area is 2 pi r plus 2 pi r times h. And last but not least, the lateral surface area, which is just around the outside, is 2 pi r h. Nice and simple. And this screen here is like a little cheat sheet for you. It gives you all of your surface area and your area problems, right? So your lateral surface area and your total surface area formulas that you could use, including a cone or a sphere down at the bottom. You guys could use all of these. And one thing you could do is if you just right click this picture in the PowerPoint, you click save picture. So you could just keep this picture separate from the notes too, and use it almost as like a little cheat sheet. So let's start off. It says a cylindrical paint roller has the diameter of 2.5 inches and the length of 10 inches. The one thing we need to know is this says diameter, right? Diameter is all the way across this paint roller. So we need to find out what half of that is to find our radius here. So that's going to be R, which is going to equal 1.25 inches. Right? This is apply the formula to determine the lateral surface area of the paint roller. So we need to find, this is a cylinder. We need to find the lateral area of the cylinder. So let's go to our cylinder screen. It says the lateral surface area is 2 pi RH. So let's write that. LA equals 2 pi RH. We know that R is what we have up here, and H, which is the length of the paint roller, is going to be 10 inches. So we can plug these in. We get lateral surface area is 2 times 3.14 times R, which is 1.25, and then H is 10. Once again, guys, Desmos Scientific Calculator is going to be your best friend here because you can plug this right in. You get 2 times 3.14 times 1.25, and finally times 10. This is going to give me 78.5. So our lateral surface area, and since we're talking about area, this is going to be inches squared, right? Because it's a two-dimensional thing. Our lateral surface area is going to be 78.5 inches squared. Awesome. Now the next one, it says apply the formula to determine the total surface area of the paint roller. Behind that paint roller, there's I messed up with my spacing here. So we need our total surface area of the paint roller, which I already remember. The surface area is 2 pi r squared plus 2 pi RH. And once again, all we do is plug everything in, and we're using the same measurements as before. So we get the surface area equals 2 times 3.14 times r squared, which is going to be 1.25 squared plus 2 times 3.14 times 1.25, and finally times our height, which is 10. And once again, you can plug this. If you're using the Desmos scientific calculator, you could plug it in just like this. If you're using other ones, you have to be careful because it might do things out of order depending on how you type them in. And we need the importance of proper order because of our order of operations. I'm typing it in to my Desmos scientific calculator. And once we get that, we get 88.3125. So we're going to round that to 88.31. So our total surface area, including the top and the bottom of this can or the paint roller, is going to be 88.31 inches squared. There we go. Nice and easy. All right, our next slide says determine the lateral surface area and total surface area of the right prism shown. The bases of the prism are shaded. Now that part's super important because the bases then can tell us what our length or width and our height are, which we need to do in our first one. So our length. Now, some of you might think, hey, well, length is like this way, right? It must be 22. But no, that can't be the length. That has to be our height because our shaded bases are here. And the height, think about a base. What does it mean? The base of something. That's the thing it sits on or stands on, right? So if we stood this on its base, 22 would be the height of this, right? So the length we could call 4, right? And it doesn't really matter which one. Our width, we're also going to say is 4, and then our height is going to be 22. So when we apply our lateral area, which we could find the formula on our previous page, two pages back, it says lateral surface area, 2LH plus 2WH. Right, so 2LH plus 2WH. So LH, so we go 2LH plus 2WH, and we could just plug everything in. We get our lateral area equals 2 times L, which is 4, H, which is 22, plus 2 times W, which is 4, times H, whoops, not H there, lol, times H, which is going to be 22. Look, these are exactly the same thing, so we only have to really multiply once and we'll be able to find both of these. So this is going to give me 176 plus 176. And that equals 352. But 352 what? Centimeters squared. There we go. Now we got to apply the formula for the total surface area. Which is basically this thing, but with something added to the front. Just 2 LW plus 2LH plus 2WH. And what does this 2LW represent? It represents the two areas of our shaded regions, the bases. Because now that's what we want on here. So basically, it's going to almost look like the same thing, except our 2LW, 2 times my length, which is 4, times my width, which is 4, plus 2 times 4 times 22, and then plus 2 times 4 times 22. Once again, we could solve each of these and then separately with the multiplication. That's going to give me 32 plus 176 plus 176. So in total, what is this going to give me? My surface area is going to be 176 plus 176 plus 32, which is going to be 384. 384 what? Once again, it's going to be 384 centimeters squared. And there is our answer. I forgot to box off my lateral answer. There we go. So once again, it's important what we look at as my length, my width, and my height here. So keep that in mind. Next up, we have a cone. We have a cone. We can tell it's a cone because it's coming to a point at the top. Our base is a circle, right? So it says determine the lateral and total surface area of the cone round to the nearest hundredth. And this is determine the slant height, S. So S is going to be what? It's this distance here. Our slant height is 6.4. And the radius of the cone, R, is half of this 10. Why half? Because 10 is our whole distance. That's called our diameter. We want this red dotted line here, which is going to be 5. Now we could apply the formula to determine the lateral area of the cone. But wait, we need to figure out what that is. So we go back, 2, 3. Do we have cone on this? Yeah, right cone. So our lateral surface area is pi r s. So pi r s. So let's write that. LA equals pi r s. And we could just plug in our information. 3.14 for pi. We said r is equal to 5. And then s is equal to 6.4. And once again, just plug this into a calculator. And what we get is 100.48. 100.48. And this is going to be feet squared. That's my lateral surface area. We're just plugging in what we know. Once again, this is all just knowing what the formula is and then how do we use it. So my total surface area is going to be pi r squared plus pi r s. Pi r squared is the area of our base, the circle that's there. And then pi r s is the rest of that cone, which we found up here. So once again, we just plug everything in. And we get our surface area is equal to 3.14. My radius is 5. We want to square it. Plus 3.14. Got my 1 that's there. 14. My radius, which is 5. And then S, which is 6.4. So the surface area is going to be what? We have to multiply this part. So 3.14 times 5 squared, which is going to give me 78.5. We already know what the second section is going to be because it's our answer right above this. We get 78.5 plus 100.48. Because this second section here is exactly our lateral area. So we add those together, 78.5 plus 100.48. We click enter. And that's going to give me 178.98 feet squared. And there we go. Awesome. Now, before we finish this lesson, we have to talk about one shape that we haven't yet. And it's a sphere, which is a ball, right? We need to talk about the volume and our surface areas of this. So the volume for a sphere is by this equation that we have up here. It says the volume of this sphere is 4/3 pi r cubed. Now be careful, because your instinct is going to be like pi r squared. But this is pi r cubed because we're in 3 dimensions. So let's use this. So it says determine the volume of each sphere with the given radius. So this is just practicing. We're given our radius right here, r. And once again, our volume formula, is we could go back. It says 4/3 pi r cubed. We're going to put 4/3 pi r cubed. We're just going to plug in our r, and we could switch pi up. We're going to get v equals 4/3 times 3.14 times, what is my R? 2.2 cubed. And once again, on Desmos, you could type it in and it will look exactly like this. So you do 4 divided by 3. You click out of the fraction, open parenthesis, 3.14, close parenthesis, open parenthesis, 2.2, close parenthesis, and then you just click the A with the little B and type in your 3. So it should look something like this right here. Typed it in. You click enter and you have your answer, 44.579. We could round that to 44.58. So our volume is 44.58, and then inches, and we're talking about volume, so it's going to be cubed. There we go. Next up is determine the volume of each sphere, the given radius, obviously doing the same thing. But now our radius is 4, R. So our volume is 4/3 pi R cubed. We plug everything in, we get volume equals 4/3, 3.14 times 4 cubed. This time I'll show you how I type it in on Desmos, right? So remember, Desmos Scientific Calculator. This is the best calculator out there in my opinion. We do 4 divided by 3, open parenthesis, 3.14, close parenthesis, open parenthesis, 4, close parenthesis, and then what we want to click to create the exponent is this AB symbol here, and we hit 3, and then we click enter. And it's 267.9, and we're going to round that to a 5. So let's write that. Our volume equals 267.95 centimeters cubed. Awesome. Next up, a half a yard is our last one. Radius. So once again, volume equals 4/3, 3.14. And then my radius is going to be 1/2. And we want to cube that. I forgot to write the actual equation, so I just I filled everything in here. Whoops. We're supposed to write our equation first. So it should be volume equals 4/3 pi R cubed, which will give us volume equals 4/3, 3.14 times 1/2 cubed. There you go. So we plug this in. Once again, I'll show you how I type it in. On Desmos, we do 4 divided by 3. You gotta make sure you click outside the fraction or else you stay in the denominator. Open parenthesis, 3.14, close parenthesis, open parenthesis, 1 divided by 2. Remember, click outside, close parenthesis, and then you click this AB symbol to get to your exponent. Click 3 because we're trying to cube it, and then we click enter. And look what it gives us, 0.523 repeating. We're actually going to write that whole thing. I'll show you how to write it. We do volume equals 0.5233, and you put a bar over that 33 to show that's going to go on forever. So 33 repeating. And what's our unit here? Yards cubed. Box off our answer. Awesome. So this last one, I'm going to leave for you guys to try yourself. If you need help with it, ask me. But remember, you just plug into the formula. What's the formula? Our volume is 4/3 pi R cubed. And this is our R. Pi is 3.14. You guys just plug that in. Use the Desmos Scientific Calculator to calculate it and try this one yourself. If you have any questions or if you need help with it, let me know, let your teacher know, or comment down below. So last thing we need to do is our surface area. Now, for a sphere, the total surface area and the lateral surface area are exactly the same thing. So they get one formula, and it's pretty simple. 4 pi r. Nice and easy. 4 pi r. So in this problem here, we have a radius of 5.2. So let's use our surface area. So we're going to say surface area equals 4 pi r. And let's plug everything in. So we get surface area equals 4 times 3.14. And then my radius, 5.2. Once again, go to your Desmos calculator. I'm not going to bring it up on screen this time. We just type it in. 4, open parenthesis, 3.14, close parenthesis. Open parenthesis, 5.2, close parenthesis. We click enter and we get our answer, and you guys should get the same answer as me. Try to type this in yourself for the practice. We get our answer. The surface area equals 65.312. And what is it? Inches. Surface area. Area is squared. There we go. There's our answer. And that is the end of our lesson today. Once again, you have to complete that one volume problem for the sphere. Try it yourself. Make sure you take the notes. Practice these problems. If you need more help, please let me know, your teacher know, or drop a comment down below, and I'll try to help you out the best I can. But thanks for watching. Hope you guys learned a little bit of something, and I'll see you next time. Peace!